Dear students, the experiment is going to be conductivity. Conductivity is the measurement of the presence of ions due to the presence of dissolved solids. The movement of ions is going to give the conductivity to the water itself. So a lot of dissolved solids, maybe due to fertilizers or soil erosion, is also quite should be avoidable because it's going to hamper the drinking itself or even for a cement construction purpose. So to estimate this one, we have the conductivity meter and then we are going to measure it. The conductivity meter here itself, this is the one, and we first calibrated. And so we kept the sample over here and the measurement is, now you can see over here, it is 24.6. What is the unit please? It is microsiemens. The unit is microsiemens. That means the conductivity of the water is 24.6 microsiemens. Now we are going to change with a new sample. For a new sample, it's going to wash with the distilled water and then it's going to clean with distilled water from the bottom and then rub by the tissue paper from the bottom itself and then we are going to dip in a new sample and a new sample we dipped it and we check the measurement. So in its measurement itself, we made measurement. Now it is coming around 1100 or 1000. The thing is, the unit you can see over here, the unit is microsiemens. That means, say for example, if this is 955 microsiemens means it is 0.9 millisiemens. That is not even 1 millisiemens conductivity. So compared to the previous sample, this sample has got less conductivity or the previous sample has got high dissolved solids ions. So right now the conductivity is around 7.77, 7.1. We have to stop the fluctuation and then we have to know the results. Another interesting fact is the student may ask, simply using a conductivity meter, is it going to solve all the problems? No. The thing is, here, as you can see, this rod itself, this rod we filled with solution with KCl. So this rod itself, orange color, it is filled with iron electrolyte that can react with the water or the sample and can give the conductivity, this orange one. Another advantage of this equipment is this is also having pH meter. So what we will do is we have another pH rod parallel to the system. So we are going to measure the same pH with this equipment. So now we are going to change. So please change the pH mode. Here we click the mode and then now the unit is coming as pH mode. So right now we are going to measure pH meter. And pH, as we all know, it is the measurement of the hydrogen concentration of the sample. The 1 to 7 we declare it as acidic pH, whereas above 7 is alkaline or basic pH. So here the first sample we will dip for a sample and then you can see the pH is coming to be around 6.8 to 7.11. It is very close to the neutral pH. And the below is the temperature 27.6. So the pH is around 7.37. Once the fluctuation is over, a reading will come out mentioning ready. Once the ready symbol comes, you can consider the sample of the pH. Another interesting fact is, if it's a very good, expensive, very sensitive pH, then the fluctuation will be very high because it's very sensitivity. For a low cost, a lot of error will be there. 7.4, 7.6, it will be considered by a single unit. So let's wait for the symbol ready to come. Sometimes the temperature also plays a role. So we have a fan, ceiling fan. Due to the movement of the ceiling fan itself, sometimes the pH also fluctuates because the temperature is fluctuating. So pH is 7.72 Slowly it's increasing. 7.74, and then 7.77. Let's have some patience. 7.79, 7.81. So fluctuation is very small. Anyway, we can consider this to be 7.85. I feel so. If the accuracy is not much required, I think because of the fan, fluctuation is there. Fine. So we'll check by offering the fan off please. So in 7.97, it's very coming close to 8. 8.01. My goodness. Anyway, let's go for the next sample. So the next sample, so now fluctuation is very, very small. 8.02, it's not moving for a long time. Okay, let's go for the next sample, please. So for this, again, we have to wash with the distilled water to remove all the contaminants of the previous samples. And then we have to rub by tissue paper again. And we will keep the new sample, clean it properly, or rather we call it wipe it properly, and then please put a new sample. Is it a new one? Okay. Now let's see the pH. Is it a new one or old one? This one is old one. Let's check with the acidic one. Yeah, correct. It's correct. This sample is an acidic pH sample. We collect it from the industrial effluent. Now, one thing very important is the sample while measuring should be completely transparent. This we obtain it by filtering the things. The presence of impurities solid also interferes the movement of the ions towards the electrode, and then it gives a wrong result. Therefore, we completely make it filter. Now you can see the sample is very much acidic pH. It's around 3.05. That means the hydrogen concentration is 10 to the power minus 3 moles of hydrogen per liter. Since 1 mole of hydrogen is 1 gram, we can say this is around 2.10 to the power 2.98 grams per liter of hydrogen ions. So this is acidic pH. So this way we measure the pH. It's very simple tool. With the help of pH meter, we are going to estimate a lot of things like alkalinity, the optimization of the jar taste, for the coagulation and the flocculation. So this equipment we are using is called octane. And by changing here the mode, we can estimate the